All right, let's look at three variables. And this one, we're going to be working with elimination and substitution again, but we're going to have to keep track of the equations because when you go to three variables, you've got to go to three equations. So you can see in number 12 that I'm going to use elimination. Notice that I've numbered the equations that'll help me keep track of them. So my first goal is I'm going to eliminate one of the variables. In this specifically, I'm going to eliminate z. I'm going to take equation 1, 2x minus y plus z equals 4, and equation 2, x plus 3y minus z equals 11, and I'm going to add them together. So that's going to give me 3x plus 2y, notice the z's cancel, equals 15. Now for this one, I'm going to label this as equation number 4. All right, next step, I'm going to do the same thing. I'm going to eliminate z. This time I'm going to do it from equations 1 and 3. So for equation 1 and equation 3, I'm going to add them together. Okay, 2x plus 4x gives me 6x. Oh, bonus here. I get the y's to cancel and the z's to cancel, so I get 18. Oh, very, very nice there. So I know that x is 3. Okay, now that I know x is 3, we're going to substitute 3 for x in equation 4. Now, why would I do that in equation 4? Well, look at equation 4. Equation 4 only has 2 variables. And because it only has 2 variables, if I know what one of them is, like x, I can go ahead and solve for y. So I'm going to plug in 3 for x. And then I'm going to turn around and solve for y. So you can subtract 9 on both sides. 2y equals 6. So that y is 3. So now you know what x is, you know what y is. They happen to be the same value. That doesn't happen all the time. So my last step is to sub 3 for x and 3 for y in any of the equations, 1 through 3. So let's do that. Well, let's do it in just one. That'll be pretty simple. 2x minus y plus z equals 4. We're putting in 3 for x and 3 for y. So I've got 6 minus 3. So I've got 3 plus z equals 4. So z is 1. And now be sure you write your answer as an ordered triplet. So you go x, y, z. Always alphabetical order. So if your variables are A, B, C, you still put them in alphabetical order. If they're D, E, F, same idea. All right, let's take a look at one more. This time we're going to use the substitution method, but before I do that, I want to highlight that this problem is key to taking test question part 2, number 4. In this one, we're asked to do the substitution method. Again, we numbered the equations to make it a little bit easier. So we're going to begin, and I think if I look at these equations, look at equation number 2, you'll notice there's not a number written in front of x. I think that's going to be my best start here. Solve for x in equation 2. So we'll subtract by 5y here. And that leaves me with x equals. Now remember, I like my variables to come first. So I always write my variable and then my number. As long as I keep the minus signs correct, I'm good. Now we're going to take this and substitute it in for one of the equations. Let's substitute in for equation 3. So we're going to substitute negative 5y plus 9 for x in equation 3. So I've got 4z minus 5x equals 4. So I've got 4z minus 5 times negative 5y plus 9 equals 4. So if we distribute, I've got plus 25y minus 45 equals 4. So I've got 4z plus 25y equals 49. So I just added the 45 there. We can do the same thing into equation 1. So let's substitute negative 5y plus 9 for x in equation 1. So I've got 2 times negative 5y plus 9 plus 3y minus 2z equals negative 1. That gives me negative 10y plus 18 plus 3y minus 2z equals negative 1. Combine your like terms here, giving you negative 7y minus 2z, and I'm going to subtract the 18 to the other side. So these equations do not look nice, do they? Substitution a lot of times can do that to us. So it's probably not my first method of choice, let's put it that way. But now that we've done those substitutions, look at what we've got. We've got 2 equations and they both have y and z. So I'm going to just stack them, okay? I'm going to put my y's first to make it a little orderly. And then here's my other one. Now, if I could get this to be a 4, a negative 4, then I could eliminate. So I'm going to multiply this second equation by 2. It gives me negative 14y minus 4z equals negative 38. I'm going to leave this first equation alone. And watch those z's eliminate. So 25y minus 14y is 11y equals 11. So I know that y is 1. Now that I know one of the values, we backtrack, right? We take one of these 2 equations. I'll take this one. 4z plus 25 equals 49. Forgive me, 25y equals 49. Plug in 1 for y. So that 4z, notice I'm going to subtract the 25 from both sides. And I get that z is 6. Backtrack even one more step, right? We need x still. So I'm going to take equation 2. X plus 5y equals 9. Let's plug in y being 1. And we get that x is 4. So my final answer, remember alphabetical order for this triplet, this ordered triplet, I should say, 4, 1, and then 6 here. So I hope that helps. Again, my preferred method is elimination, although you can see I did substitution. It's just not my favorite nor one I would choose to be the easiest. So hope that helps.